Well, hello there, fellow members of the Homo sapiens species, ready to uncover the origins and the secret code that links animals, plants, and us humans. The evolutionary history and relationship of all living organisms is called phylogeny. A fancy word, isn't it? A little bit confusing, but it is basically just the ultimate family tree, showing us how every living thing is related. It's not just about how they look, but also about their shared evolutionary journey. For example, it reveals that whales are more closely related to hippos than to fish, and that fungi are more closely related to animals than to plants. Mind-blowing, isn't it? With the vast intellectual powers of these scientists, methods and techniques were developed in order to determine its close relativity. Reading one's DNA and comparing it to another shows that different species come from common ancestors. Have you ever seen the elongated neck of a giraffe and subsequently comparing it to your own and thought to yourself, man, these aren't structurally the same as the one in that magnificent beast? However, when you fully delve deep into the bone structure of humans and giraffes, we can see that they both have 7 neck bones. Combined with a similar bone structure that pertains to these animals, leads the scientific community to posit that humans and giraffe both came from one common ancestor. This is what we call as homologous structures. Proposed by Sir Richard Owens in 1843, homologous structures are organ or skeletal structures that are alike to each other. The forelimbs of a human, whales, and birds are examples of these. This is a method used to determine relatedness. Analogous structures are basically the antithesis of homologous structures. They look and function the same, however, they do not come from the same common ancestors. Take a look at the legs of a cat and a praying mantis. Functioning the same, which is to be used for walking. However, their structural integrity is very different from one another, which suggests that they do not come from one common ancestor. Additionally, there are vestigial structures that provide little to no purpose at all. These could be used to provide insight on an organism's ancestry. For example, are the vestigial leg bones of a snake, suggesting that they had a 4-legged common ancestor. So all in all, phylogeny lets us dig deep into our evolutionary roots that connect all living things. By comparing DNA, studying physical structures, scientists can piece together the intricate web of life. I hope you learned something from that little educational escapade that we've had. Well, until next time guys, see ya!